Let's consider the following directed graph. The source and destination vertices have been marked, and let's say for this problem you're given that k is equal to 5. That means you're allowed at most 5 stopover points along the route from the source to the destination. So another way to say this is the total number of edges along the shortest path must be less than or equal to 5 plus 1 or 6. So there should be at most 6 edges along the shortest path. Now when Dijkstra's algorithm runs on this graph without any tweaks, it would naturally find that the shortest path from the source to the destination is basically this path which I am coloring in yellow, which has a total cost of 7. So 7 is the length of the shortest path from the source to the destination in terms of the cost. Unfortunately though, this path of length 7 uses 6 stopover points in the middle. If you count the number of edges used along the path, the total number of edges used along the path is 7, which is more than 6. 6 was our upper limit. So the plain Dijkstra's algorithm is going to end up violating the constraints of the problem. And so let's think about the tweak that we proposed in the last video. According to that tweak, once we reach this particular vertex, this green vertex over here, we would have already used up 6 edges from the source to reach that green vertex. Right? These are the 6 edges which I've colored in green. So I can't extend this path any further beyond that vertex, and so what the tweak proposed was to drop this cut edge from further consideration. It's no longer going to be treated as part of the graph. So what would be the shortest path distance to the destination then? What Dijkstra's algorithm would do is it would walk along this longer path from the source to the destination using 3 edges and with a total cost of 10 plus 10 plus 10, which is 30. Right? This is what the tweaked version would do, because the cut edge from this green vertex to the destination was dropped. So the only way now to reach the destination is via this long path whose cost is 10 plus 10 plus 10, 30. The question is this the shortest path from the source to the destination that uses at most 6 edges? Well, if you think about it, the answer is no. If you consider this path, which I am coloring in grey, from the source to that green vertex, let me call that green vertex as X, this grey path, if extended with that cut edge which we just dropped, would make us reach the destination with a total cost of 5 plus 5 plus 3 plus 1, which is 14 units, and it would have exactly 3 stopover points. So it wouldn't be violating the constraints of the problem. The total number of edges along it would be 4. 4 is less than or equal to 6.
Want to become a software engineer at Google? You can, like thousands of our students. You just need to learn from those who've already cleared FANG interviews. At Interview Kickstart, our interview prep courses are developed and taught live by 150 plus instructors from Tier 1 companies like Google and Facebook. Our courses are tailored to help you crack software engineering domain interviews, including back-end, full-stack, machine learning, embedded systems, data science, and more. To learn more, book your free webinar slot today